So hello guys, welcome back and let's discuss some really interesting problems of our mock tests and past year IIT JAM question paper, and let's get started right away. Okay, so let's do this problem. I think this doubt is given by Dibbangana, and let's see how we can approach this problem together. So if you observe this problem, it asks, so many of the problems are about UMVUE, okay? So let's understand and let's learn how we can find out UMVUE and what are the methods to do the UMVUE. Okay, so number one is that an UMVUE is, you find an UMVUE from the fact that it's a function of the, I have already told you many times that it's function of the complete sufficient statistic. It's a function of that, and it's unbiased. So by using Rao, Blackfell and Lemon-Shefe, we can comment on this, right? So therefore, using these two properties, we have to find something that is a function on like it's a function of the unbiased of this of a complete sufficient statistic, and it's unbiased. So first we have to find the complete sufficient statistic of this. Okay, so we have shown something previously. In fact, Romit was also in that class. I remember that we were discussing that when we can find out how we like, is a function of the complete sufficient statistics a complete sufficient statistic? Is it true, guys? Is a function of a complete sufficient statistics a complete sufficient statistic, guys? Yeah. Does there exist such a theorem? So anyway, so let's understand this. So if it's asked about e to the power minus theta into theta cube, the question is, therefore, my question is that f of theta is there. So you may know a complete sufficient statistic of theta. What is the complete sufficient statistics of theta f theta? That's the question. Let's say this is, in this case, this is x bar, that is t. Okay, t is complete sufficient for theta, okay, since it's point show. So it's t. So is it f of t or something else? That's the question. Do you understand, guys? Is it f of t? Okay, so that's the question. What do you think? Or is it t? Is t also complete sufficient for f of theta? Yeah. What do you think, guys? Please tell me. If t is complete sufficient for theta, is t also complete sufficient for f of theta? What do you think? This is something you should be telling right now. Hello, hi.
T is also sufficient for f theta for completeness, but invertible function is complete.
T is sufficient for f theta, okay. And for?
If function is invertible, then T is also complete for f theta.
If the function is invertible, then t is also complete. Very good. See, if f is invertible, bijective rather, t is sufficient, t is complete. We can prove that. We have proved this a lot of times before. Okay. So now let's apply this. So do you think this is it's a bijective function of theta? Is this bijective function of theta, guys? Yeah. What do you think? E to the power minus theta is, to theta is decreasing, right? And theta cube is increasing, right? So their product is, So their product is
decreasing,
good. So is it bijective? Is it bijective? At this point of time, you should be telling this. Is it bijective? Hi. Good. It's bijective. So it's bijective. Since it's bijective, T is complete and sufficient for f of theta. That is, in this case, it's to the power minus 2 theta, theta cube. Okay. So now you have to find the function of T. Therefore, g of T such that expectation of g of T is this. Did you understand the steps, guys? First step is to find a complete sufficient statistics for f of theta. And then the next step is to find an unbiased estimator, which is this, which is okay. So can you tell me when does an UMVUE, when the UMVUE doesn't exist? Can someone tell me when UMVUE doesn't exist? Does UMVUE always exist? That's a very interesting question. Does UMVUE always exist? Does UMVUE always exist? Huh? When does the UMVUE not exist? Tell me. So the fundamental questions you should be asking right now. You have 1 month of exam left, and if you can't answer this right now, that's bad. Does UMVUE always exist? Yes or no? Why? Give an example. So let's say this comes or this is asked. So what will you write like? Give an example where UMVUE doesn't exist.
For Poisson distribution, we cannot estimate 1 by theta. So in that case,
Okay. Let's understand this. So a Poisson distribution, we cannot estimate.
We cannot estimate 1 by theta.
1 by 2 lambda.
1 by theta.
1 by theta. Why? We cannot estimate 1 by theta. Is it a right way of telling that? For Poisson distribution, we cannot estimate 1 by theta.
I mean, we cannot unbiasedly estimate 1 by theta.
Yes, you should tell that. Unbiasedly estimate. Yes, we cannot unbiasedly estimate 1 by theta. So if you cannot unbiasedly estimate 1 by theta, why we cannot? Let's prove that. So for Poisson distribution, we cannot unbiasedly estimate 1 by theta. So x1 x2 xn follows Poisson theta. So let T be an unbiased estimator such that expectation of T is 1 by theta. So why we cannot do that? Can you please tell me? How do you do the proof? Expectation of T is equal to T. There doesn't exist such a T. Why? Yeah, please tell me.
Because we can write the expression as summation term and compare the coefficient of power.
Okay, very good. So T, and if you check the coefficient, so it's T times T summation this, right? Am I being right? Am I doing wrongly? Is this the idea?
Here T, then T plus Poisson n theta.
Oh, I'm so sorry. Just give me a minute. This is the T of X. I'm doing something terribly wrong. Just give me a minute. So how will you calculate this? My mind is not working. How will you calculate this? Wait a minute.
We know that T follows Poisson and theta, and we use the PMF of that distribution.
T follows Poisson and theta.
Yes, reproductive property. T is summation exponent.
Oh, but wait, why will we do T as summation xi?
It's given in the question like that.
No. Here the question is that he told like there exists no unbiased estimator of 1 by theta. In that question I'm trying to solve. He told there is no unbiased estimator of 1 by theta, right?
Yes.
So how do you prove that? That's what I'm asking. I don't know why my mind is not working. Anyways. Yeah, so why unbiased estimate doesn't exist? Tell me. Are you sure it's for this or something else? Yeah. I think what you try to mean is the following. It's not x1, x2, xn, but just for a single x, right? A single x follows point. So this at t is a function of x. So therefore, the by law of unconscious statistician, that is, it's a function of x. So therefore, t is from not t, but t is a function of x times this theta to the power x from 0 to infinity. X is just one observation. That is equal to 1 by theta. Does it seem familiar, guys? Huh? Does it seem familiar?
Yes.
Okay. So therefore, you get that theta to the power x plus 1 by x factorial. This is equal to 1. And I guess if you do it theta e to the power theta on both sides, this is this. So I think that e to the power x has some expansion, right? So what is coming out from here? Can you tell me? We can get something about t of x, maybe. Is it true? E to the power theta can be please tell me what we can write out here. We can write I think theta will be taken common over here. 1 plus. Tell me what we'll write over here. We can compare, right? Theta by what should be? This is the idea. So if we compare, what we will get? What we are getting? What we are getting? Tell me.
Here we are getting 1 equal to 0 because in left side
Yes.
theta power at 1.
Yes, very
And
good.
from right side, it's supported.
So we get that there is an extra 1 over here, so which is not possible because theta ka power starts from 1, not 0. Therefore, the unbiased estimate doesn't exist. So if an unbiased estimate doesn't exist, we cannot tell an UMV always exists, okay, for a certain parameter. So therefore, you have to find out that you have to find a sufficient statistic, a complete sufficient statistic. Just give me a minute. You have to find out a complete sufficient statistic for which, just give me a minute, it's reloading, for f of theta, right? So this is how you find it. So we have got this. Now you have to find out a function of t such that its expectation is equal to this. Now can you tell me like what you can actually find a similarity with the expectation? You have to try to understand with what you have to can find the similarity of this parameter. Can you tell me with what you can find the similarity? What is e to the power 2 minus 2 theta theta cube?
It is something constant into probability x1 equal to 1 and x2 equal to 2.
So its probability e to the power minus 2 theta into theta cube is probability is something, right? You have to understand what is that something. It's probability what?
Probability x1 equal to 1, x2 equal to 2, and something constant. But multiplied by something constant.
Okay. So okay, let's see what is e to the power minus 2 theta. Um, it's Poincare theta. So if you observe that, so probability x1 is equal to 1 is what? X1 is equal to 0 is what? Let's understand that. It's e to the power minus e to the power 0, so it's e to the power minus theta. Okay. Probability x is equal to 1 is what? E to the power minus theta theta. Probability x is equal to 2 is what? E to the power minus 2 theta times theta square by 2. Right? Sorry. So observe that if you multiply this 2, then you get something. So therefore it's equal to half times probability x1 is equal to 1 and x2 is equal to 2. Did you understand that, Dibbangana? Did you understand that, Dibbangana? Please say yes or no. Others also. I hope others understood that. Anyways, so half times this. Sorry, I think 2 times this. 2 times this. 2 times the probability. And also xi's are independent, so that's also the same thing happening. Now, like just the constant multiplication. So observe that this. So now how will you express this? How will you express this? So whenever a parameter is actually a probability, so you express it by, so use the indicator random variable idea. Because expectation of any indicator of a set A is equal to what is probability of that set A. Okay. So you do it twice, so you get twice of this. So therefore you have to therefore it's nothing but e to the power minus 2 theta theta cube is nothing but expectation of this indicator random variable twice times indicator x1 is equal to 1 and x2 is equal to 2, right? From this indicator random variable idea, we can get that it's nothing but expectation. This, did you understand this? I hope Dibbangana is understanding because it was hard doubt. And she is not replying. Anyways, so did you understand till this point of time, guys? Till this point, did you understand this? Okay, great. So now observe that how will you approximate this? So it's expectation of this, and it's actually a but this is not a function of the complete sufficient statistic. Okay, but we have got an unbiased estimator U. So we have got an unbiased estimator U, and we know a complete sufficient statistic, that is T. So therefore, we can do what? We can find expectation of U given T. By Lehman-Schaffer, you can find out this expectation of U given T. This is the UMVUE. Did you understand that? We cannot directly find out that, but we can find out expectation of U given T is equal to UMVUE. Right, guys? Do you understand that? Now we'll calculate the UMVUE right now. We'll calculate the UMVUE right now. It's confusing, Nitish. Where you're confused, please tell me. We're using the Rao-Blackwell theorem. I hope you are appearing for the examination this year. Nitish on the live. Okay, let him answer. In the meantime, we can progress, I guess. So therefore, you have understood that expectation of twice of indicator x1 is equal to 1 and x2 is equal to 2 is U. This is U because it's unbiased estimator, and we know that T is equal to summation of xi from 1 to n. This is a complete sufficient statistic. So we have to find out using Lehman-Schaffer that its expectation of U given T is equal to T. That is, you have to find expectation of twice of expectation. So it's like twice of expectation of twice of indicator. x1 is equal to 1 and x2 is equal to 2. Given the fact you know it's summation xi I from 1 to n is equal to t. Now expectation is probability, so you can write out this is nothing but probability. You can write twice of probability x1 is equal to 1 and x2 is equal to 2 given summation xi, because yeah, this is the idea. You can write this as probability. And now yeah, it's nothing but a conditional probability as calculations now. The calculation now. So how we can find this conditional probability? It's very easy. How can you find this conditional probability? Just use basic stuff. x1 is equal to 1, x2 is equal to 2, and summation of xi is equal to t by probability of summation of xi, that is equal to t. Now you find out, you will get a function of t over here. You know this. So this and this, therefore you get its summation of xi from I. So it's same as saying that it's from I to n, it's t minus 3 because this two are already given. So now these are IID. Okay, so you can find out, write the joint distribution out there. Okay. So do you want me to write the joint distribution out? Dibbangana, others, do you want me to write the joint distribution out? Or will you do it yourself? Yeah. You can? Perfect. Okay, let's move to the next problem. Very good. So now, so we have used this is the core idea of using What? This is a core idea of using the laymanship, okay? So what is the first step? The first is to find a complete sufficient statistic. The parameter complete sufficient statistic will always not be a complete sufficient statistic of the transform parameter. You have to check that. That step many people miss that, okay? So check that. Let's do this problem. It's another UMVUE problem. So in this UMVUE problem, assume the number of monthly incomes of the employees in Cheenta Academia distributes Pareto, whatever. And suppose this is a monthly, then the UMVE of A. So essentially, it's asking about the UMVE of A. This is a like just like to make the integer type or whatever that is. It's asking about the UMVE of A. So now, f of x is nothing but this constant 0.1 a to the power 0.1 by x to the power 1.1. So x is greater than or equal to a. This is given. So what will be the UMVE of a? This should be understandable, guys. What should be the UMVE of a? Huh?
X order n. I mean maximum.
X order n or x minimum m?
Here
X.
all x will be greater, okay?
Minimum.
Minimum.
Yes. So it's minimum. So the complete sufficient statistic, we can show that this is the minimum. Not the, I mean, sufficient statistic is the minimum. Complete sufficient is the minimum, okay? You can show that. Something you can show. I have to show it again. You have to find the minimum distribution. You have to do the expectation. It's the same thing, okay? It's the same thing. So you can show the complete sufficient statistics of the Pareto distribution, okay? It's a minimum. And from that, you have to find the distribution, guys. So now you have to find a constant. You have to find the distribution, find the expectation. Find out the expectation. You will see some constant is coming up. If some constant is coming up, just add it over there so that it becomes a. I hope that comes out. So so you have to find the expectation of that. So I hope you understood the algorithm, just like uniform. Okay, follow me. Do it just like uniform.
But I think
Oh, did I do some mistake? Yeah, please.
it is not it.
Yeah.
Because Pareto distribution for it is a he can get a bar something red.
Okay, so he is telling that maybe Pareto distribution ka. I don't know the expectation of Pareto distribution, so let me just check it online. Otherwise, I'm just trying to minimize the time of our doubts. Okay. So Pareto distribution ka. Okay. So the mean is defined for alpha greater than 1, number 1. Okay. So I think there is a mistake in this question. I think that 0.1 times a whole to the power 0.1. So it's a Pareto distribution mean is this. It's alpha times x to the power, sorry, a to the power alpha, as far as I can see, by x to the power alpha plus 1. So we have put alpha is equal to 0.1. But the thing is that the mean is turning out to be infinity for this case. Can you just check it's turning out to be infinity? So I think this question is not right. If it was 1.1 and 1.1 and 2.1 here, then it would have, the mean would have been But it's a valid question. What is the UMVUE of A? If the mean is greater than or equal to 1, the alpha, then the mean is turning out to be alpha A times alpha minus 1. Okay, so let's do it for this only. I think this question is a bit wrong, but let's do it for this. So pattern distribution का mean for alpha greater than or equal to 1 is alpha A by alpha minus 1. So I think, I mean, what did you tell, Romit? I didn't understand your doubt, maybe.
Yes, I was saying that here for that value of alpha, the expectation is not defined.
Oh, okay,
As you are
okay.
getting, this is complete.
Okay. So I think there's a issue is in question. I think it should be um, alpha greater than or equal to 1. You're right. So maybe yeah, alpha greater than or equal to 1 ke liye it's defined. Yes. So UMVUE is not defined, but do you know what the UMVUE comes out for standard distribution? Do you know the maximum minimum distribution or what? So anyway, so I hope you understood the method, right, Ptolemy? The method of doing the whole thing. So what is the method? I'm repeating again. So when you have this restricted support space, like depends on the parameter, what you do is the following. You first find out, I think it's ideally the first order statistics or this order statistics. Ideally, it's not always, it's ideally in the ideal case. You find out the distribution of them. If you find a distribution, you take the expectation of the x1 or the maximum order statistic, xk, let's say, and you find out, let's say, some constant times some parameter theta, okay, whatever. Now you take that constant on this side, so you get just like the uniform. Okay, did you understand, Ptolemy? Yeah, did you understand, Ptolemy?
Yeah.
If it doesn't work out, do let me know. Okay, next problem. Anything anyone wants to add? Okay, let's see what else. X1, X2, Xn for points show theta. You guess that when n is large and lambda greater than 0, then what is the maximum likely estimator of the asymptotic standard error of the MLE? Okay. What is the max MLE of the asymptotic standard error? C to the power minus theta. C to the power minus theta का MLE क्या होगा, guys? Tell me. E to the power minus theta का MLE?
6 bar.
E to the power minus x bar by the invariance principle of MLE. Very good. So now if it's e to the power minus x bar, इसका what do you need to find? Expectation of, sorry, you find the variance of this, right? Variance of this, right? So find out the expectation of this first. Expectation of iska whole square, that is e to the power minus 2x bar. So xi are independent, so it's very easy to calculate. It's very easy to calculate. It's e to the power minus 1 by n summation of xi e to the power minus 2 by n summation of xi. So it's nothing but, you can easily understand, this is nothing but the expectation of, so if mt is the expectation of e to the power tx 1, let's say, then this is nothing but what? M of minus 1 by n whole to the power n, and this is nothing but m of minus 2 by n whole to the power n, right? Did you understand, guys? And if you have found out this, you can find out the now limit. You can find each of the individual limits. Okay. Can you just tell me what is the? I mean, I forgot the method of like the moment test. What it's called? Moment generating function. I forgot the moment generating function of point show. Can you please tell me what is the moment generating function of point show?
For Poisson lambda, it's e power lambda into t e power t plus 1 in exponential
फिर
only.
से बोलो
minus
e power theta times
et minus 1, e to the power t minus 1. But theta into e to the power t minus 1.
this one.
Yes.
Okay, so if you have this now, this is the empty. So now m of 1 by n is what? E to the power theta, e to the power 1 by n minus 1. And e to the power 2n is what? M of minus, oh, there's a minus over here. Minus 2 by n is e to the power theta times e to the power minus 2 by n minus 1. As n tends to infinity, what happens? This is n, this is n, whole to the power n is this. So you have just a limit now. Let's calculate one of them, then you can find out the other. E to the power, let's calculate this. E to the power c by n minus 1 as n tends to infinity. As n tends to infinity is nothing but n times e to the power c by n minus 1. So observe that this goes to infinity and this goes to 0 and this goes to 0. So it's a L'Hopital format over here. Okay, although it's n, it's a sequence. So you have to find this limit. It's a limit problem now. C to the power n times theta e to the power c by n minus 1. Limit n tends to infinity. How will you find out? Same as e to the power limit n tends to infinity n theta. Tell me, what is this? How will you find out this? Tell me, how will you find out this? Any ideas? So it's same as asking limit n tends to infinity n times e to the power c by n minus 1. So how do you find out this in limit?
We can use the velocity extension of t to the power p by n.
Okay, so tell me that.
Then one is getting cancelled. As it is limit n tends to infinity n into p by n plus something terms that are 1 by n square or more.
Very good. So it's c, right?
Yes.
It's c. So you can understand it's nothing but e to the power theta c, right? So therefore the variance of e to the power minus x bar variance of e to the power minus x bar is nothing but e to the power theta minus e to the power minus 2 theta, right? Sorry, I think there's something. Wait. Variance of I did something wrong. E to the power, sorry, expectation of x bar उसका whole square. Just give me a minute. Is it coming out to be 0? No, I guess. Variance is coming out to be 0, guys. Can you just check? Romy, did you do this problem? Nikhil, did you do this problem?
Yes, I saw a data. I saw a data that the asymptotic variance of MAD is same as CRA.
Okay, but okay. Yeah, that
I don't
is
know the proof.
true, but I think we can do this in this manner, right? We are finding out. I think we can do this in this manner. It's quite doable now. So what is the problem issue is over here? What is the CRLB? Do you remember the CRLB? C to the power x square minus this whole square. So it's coming out to be 0. I don't know why. Did I do any mistake? Guys, did I do any mistake, guys?
Means in one part the limit is coming out to be -2 and another one is -1. Then
No.
that's where
E to the power minus 2 theta and e to the power minus theta, and we have to now therefore do it e to the power minus 2 theta minus e to the power minus theta whole square, which is e to the power minus 2 theta. So it's coming out to be 0. So this is the issue. So this is the issue. Oh, I think I didn't consider this. Oh no, it's fine, I guess. It's C only. What is the issue, Romit? What do you think? What is the issue? Nikhil, Paulami, Shana, Dibbangana. What do you think? What is the issue in this proof? Did I do any calculation mistake or the variance is really 0? The variance is 0, then this shouldn't have been the option. Minus 1 by n, so that is coming out to be minus xi by n whole to the power n. That is true.
Sir, 1 minute, can you show the limit? I think that I don't know whether the Taylor series we can actually use that at all. Like the form is doubtful.
Okay, you're telling this limit is not right?
It is 0 into infinity form here. So can we actually use the Taylor series expansion?
Yeah. Like, what is Taylor series wrong? Why is Taylor series, do you think, wrong here? Yes, you can use that. So this is confusing. This is really confusing. So variance of e to the power minus x bar is coming out to be expectation of e to the power minus x bar x2x bar minus expectation of e to the power minus x bar whole square. So this is coming out to be e to the power minus 2 theta, and this is coming out to e to the power minus theta whole square. It's coming to be 0, and this is very weird. I mean, asymptotic variance of the MLE with theta though. What is the issue, guys? Tell me. If I done any mistake, please tell me. Do you find any mistake over here?
Right.
Huh?
Because the variance in limiting step tends to zero. I think that is right. Because we know image is consistent. So variance maybe zero. Right.
Oh, in that sense, yeah, MLE is consistent. You're right. But I'm trying to understand the maximum estimate of the asymptotic standard error. In that sense, is right. So, oh, I see. Okay, okay, okay. So asymptotic standard error, by that it doesn't mean the variance. It includes n. Okay, if you observe that. No, no, no. Wait, what I'm saying. So actually, it should be. Yeah, you're right. So this is the problem is wrong. This problem is wrong. Yes. So I will just tell the people out here. This problem is wrong. Yeah. So you understand that. Thank you, Romit. It makes sense. So I said the MLE is consistent. So this must go to 0. Okay. But what is meant by the question is the following: is that um, it's like standardized of certain. I mean, standardized aspect like MLE is MLE ka asymptotic distribution. It meant okay. Asymptotic variance, it means asymptotic distribution. So asymptotic distribution is something like this. What is meant by asymptotic distribution is the following. Okay. What is meant by asymptotic distribution is the following. It's a part of large sample theory, but it's okay. It's good to know stuff better than more than that. So what it meant is the following, is that it should be 0, okay? It should be 0, that I know. But the thing is, there is a asymptotic normality property, okay? Asymptotic normality property of MLE. So just let me write down the result. Is asymptotic normality property. By asymptotic normality property, what Romit saw is the following. I will tell you. So the asymptotic normality property is this, that of MLE is this: root over n theta hat MLE minus through parameter theta goes to normal 0 comma certain sigma square, certain sigma theta square. This is dependent. This is like there's a root n extra root n parameter, there's an extra root n score. That's why it's 1 by n, so it will go to 0. Okay. So what it means is the asymptotic variance means this, where root n times MLE theta hat is going towards. Okay. Iska variance is asking. So variance of root n times this, it's asking actually. That is, it's 1 by n variance of theta hat MLE, it should ask. So therefore here it should be in this format, that it's all 1 by n, okay? So it's asking the limit in this. So it's your homework. Let's do this homework. So it's asking the limit of n tends to infinity 1 by n, okay, e to the power what? N theta e to the power minus 2 by n minus 1 minus of e to the power n to n into this. Okay, this goes to 0. I think there is something wrong. Just give me a minute. Okay, so no, it's n times this. So it's n times. So variance of this is nothing but n times variance of this. Sorry. So n times of this. So I have to find the variance is infinity times this. So what you have to find is the limit of this, not that. This is what it means by asymptotic variance. Asymptotic stuff. Okay. So this is what is meant by asymptotic normal, like asymptotic variance. This is what it meant by that. So now find this limit. This is an interesting limit, I guess. This is an interesting limit. Can you find this limit, guys? This should be some constant. And this is what I think Romit will find out. Like did find out by the CRLB. So can you find out this, guys? It's very interesting. So again, you can use that. I mean, it's coming out to be a bit more involved actually, but you can use the double aspect of Taylor series. So how can you find this limit? So find the sequence out. Find the limit of the sequence. Okay. Find the limit of the sequence. I'm just giving it as a homework. So find the limit. Find the limit. This is the asymptotic variance of MLE of the problem. Okay, so find out the limit, guys. I think it can be easily computable. Okay, I hope you understood the idea, guys. Polemy, I hope you understood the idea. So now you will find certain parameter over here. I think it should be proportional to theta or something like that. Or I don't know, like I don't know what it should be, but I don't know like how it should be. But whatever it is, it should be, it contains it's a function of now theta, right? It should be a function of theta, right, Polemy? So now you use that same g of x bar. Okay, did you understand? Use that same g of x bar. ठीक है? Follow me? Did you understand?
Yes, yes.
Okay. Next problem. Same UMVUE. So this is an UMVUE I already told before a lot of times. Follow me, why couldn't you do it? This is very easy. So Pika estimate is what? Pika UMVUE is what? X bar or summation T, let's say T. Pika UMVUE is T or its complete sufficient statistic is T, right? Complete sufficient statistic is T. Now P to the power alpha complete sufficient statistic is also T. Since it's a one-to-one function. So to find the function of T such that uska expectation is P to the power R, and I have used a recurrence relation. If you remember, expectation of T, it's like T are what? T follows binomial n comma P. So expectation of T is what? You know it's NP. Expectation of T square is also confined by variance, right? NP times 1 minus P minus NP. So you can find like this, and you can find a pattern out there. You can find a pattern out there. You can find a recurrence relation actually. So find the recurrence relation of expectation of T to the power n with expectation of T to the power n. Find a recurrence relation with this. There is an easy recurrence relation. Okay. Find a recurrence relation with this. When you find the recurrence relation, you know you can find. Did you understand, Polemy?
Yeah, actually, what I knew was that the UMV of P to the power R or something like that will be P choose R by N choose R. Some means the structure will be like that, but Here, yeah, it is n minus r choose t. So
N minus R, choose T. So there are a lot of options now.
means all are of the same kind that n choose something, not t choose r. Means the structure I was not familiar
So please
with.
send your solution handwritten. So let's find out till send your solution in the WhatsApp. I understood, like I thought that you didn't understand the method. I hope you understood the method, right?
Yeah.
So you find out expectation of t to the power n ka, like what it will be in terms of t to the power r minus 1. So find it out. Like send me a solution problem, okay? Whatever you have done it, okay? ठीक है?
Yeah.
Okay, let's move to the next problem. I think we will move ahead to the problem of. So this question is a very I cannot see it. So why don't you give the actual questions? Why did you take pictures? I don't know. Nikhil. So one and
For the last problem, will you repeat your process or your process now means what you said?
this one.
Yeah.
My process is same. Like you find out expression of t to the power 2, t to the power 3, and you can find the general relationship with the expression of t to the power n, expression of t to the power n minus 1. The relationship is called recurrence relation. From that, you can find out a recurrence relation of. You can find out a general formula of UMVUE of p to the power r, or p to the power n, or I mean p to the power r. Okay. From that, you can find out the general formula of that. Okay.
Okay.
So you have to form the recurrence relation. Without the recurrence relation, you cannot extend the idea. You cannot extend the idea with the recurrence relation. With the recurrence relation, you can extend that idea. Just give me a minute. Okay, so let's move ahead to now this whatever random sample from normal mu comma sigma square is given. Find the unbiased estimator of mu by sigma square. Unbiased estimator of mu by sigma square. Can you give me an estimate of mu by sigma square? Let's forget unbiased estimate. Can you give an estimate of mu by sigma square? Nikhil, can you give an estimate of mu by sigma square? Anyone? Paul, Nikhil, Dibbangana, Shana, Romit. Can you give an estimate of mu by sigma square? Anyone?
Mean by sample variance.
Mean by sample variance, right? Okay. So we have to find an unbiased estimator now. So how do you find an unbiased estimator? So can you find out mean by sample? Yeah.
For normal distribution, we know sample mean and sample variance are independent.
Very good. So it follows. So, yeah. Go ahead. I'm sorry. X bar by unbiased x bar by 1 by n. I think this one. Yeah, please go ahead, Remit. Please go ahead.
And we have to find the unbiased estimator of 1 by sigma square based on sample variance.
Okay. Did you understand the idea, guys? What he is telling is the following. So x bar ka expectation is mu, and x bar is perpendicular to the sample variance. Like you can say it's summation, like summation xi minus x bar whole square is independent to this. So if we can find a function of this, let's say this, let's call it whatever, something a, let's or t. Let's if you can find a function of t such that expectation of the f of t is equal to 1 by sigma square. What will be helpful? T and x bar is, so therefore expectation of x bar is mu. So therefore, since x bar and t are independent, x bar and f of t are independent, so their product is what? Is mu by sigma square. Now, can you find such a t such that f of t ka expectation is 1 by sigma square? Can you find such a t? Nikhil, did you understand?
Yeah.
So, can you find such a t?
It is something constant into 1 by t.
Okay, so how do you get that? By chi square?
Because, yes.
Okay. Yeah, please go ahead. I want you to tell the solution. I was just verifying. Yeah, please go ahead and tell the solution. So he's telling that some like 1 by t. So yeah, please go ahead. Please go ahead. Please go ahead. Yeah.
We know is that xi minus h bar square by sigma square follows chi square n minus 1. And expectation of 1 by chi square n minus 1 is being calculated.
Expression of 1 by chi square n minus 1 is 1 by chi square n minus 1 is
I have not done the calculation.
oh. So how do you find 1 by t ka? Okay. So
So for this problem, like you have to write the chi-square PDF only and integrate. Like there's no other way. I tried. That is why I wanted to see if there was some other way, but like this is the only way. You need to take expectation of 1 by y, where y is chi-square n minus 1.
no, I was thinking of this method. Okay. So just let me know if it's fine or not. See if this is the idea. So we know. I think that will not turn out. I think 1 by t will turn out there. Yes, I think that is turning out there. So you need to find the 1 by t distribution. You're right. You're right. You're right. To find the 1 by k distribution.
Means by moment we can go. Means if we know the moment of
If you know the moment of
chi-square, then expectation of 1 by t.
from moment, how we can do it? I think we will do from chi-square. I-square का PDF क्या है? I forgot. Can you please tell me? It's 1 by t times the PDF is
e to the power minus x by 2.
e to the power
Sorry,
minus t by 2.
To the power minus t by 2. T to the power n minus 1. N minus 1 by 2 minus 1.
Okay, so if you do it, you can see like it's coming. So you can find out it's a chi-square sum. Okay. So maybe it's n minus. Yes, I think is it n minus. It's if you just see if it will turn out to be n minus 3. Is it right? I mean, is it right? I mean, what you told? Like, I mean, what I mean to say is that, I mean, it turns out to be 1, I guess. No, not 1. I think I'm doing some mistake. Just give me a minute. Just give me a minute. So T by sigma square. This follows chi-square n minus 1. So expectation of t is 1. Expectation of t is coming out to be 1, right? Or what? Some error is going on. It's coming out to be n minus 3, right? Chi-square n minus 3 ka PDF is coming out, right? This is what? This is coming out to be this. So it follows the PDF of a chi-square n minus 3. Is it correct?
Yeah, n minus 3.
Is it correct? Romit also? Is it correct? I don't.
Yes, yes.
So anyways, there can be some small errors. Please check this distribution. It's 1. So expectation of t is 1. So expectation of 1 by t is 1. Oh, I think there will be a sigma square over here. Sigma square by t. Sigma square by t. T by sigma square follows that. So expectation of
In PDF, there was also a denominator part.
yeah.
In the PDF, there was also a denominator part.
Oh, what is the denominator?
It was for gamma, for chi-square n, it should be gamma n by 2. We have n minus 1 by 2.
Okay. I understand. Okay, so that constant will be added. So there will be some constant. Okay, some constant, and 1 by sigma square. How it coming up? That's what I'm trying to understand. 1 by sigma square. Where it's coming up from? Where is 1 by sigma square coming up? Oh, I guess. Okay, this follows chi-square this. So 1 by z follows the expectation of 1 by z will be something like constant. Okay, that constant coming up. So therefore expectation of sigma square by z t will be c. So it will be 1 by t, ct will be 1 by sigma square. Yes, you're right. So yeah, that's the idea. Yeah. So it will be, did you understand? Nikhil, follow me. Nikhil, Dibangana, Shayana. Did you understand, guys? Romit. It's very simple. I'm doing it very fast because now you should do things fast and quickly. Okay, so let's move to the next problem. So is the hypothesis H0 versus H1 is in test statistics T. Proposed response is not support. T is large. Okay. Based on a given sample, p value of it is computed to be 0.2025, assuming distribution of T to be H. Okay. If the distribution is okay. So what is p-value? Can you tell me what is p-value? What's the definition of p-value?
What the other done that we offer the value same as the other of t.
Let's say t is equal to t is observed. Okay, and t is a test statistics, so it's asking we reject when this happens. So this ka probability is coming out to be this. It's given. Now assuming the distribution of t is normal, it's calculated to be this. But they're saying that this distribution is, so under h naught. So this is the idea. What is they saying that we know that if t is normal, therefore what is this? The t is what? Z 0.005. That is what they are telling. And they are asking that what is the probability that therefore with that t distribution, now the t distribution t, let's call it whatever, the new xi, not xi, but the new, let's say t dash is greater than z 0.005. So what is asking? Let's understand this. So normal distribution is symmetric. Can you tell me what is t distribution? How it looks like? This is z 0.05. T distribution?
But it has more tail curve.
Say like this.
More tail protein and then cheese protein.
So therefore, this is normal, let's say. Therefore, t will be like this. Or t will be like this. T is like this. Huh?
Yes.
Good. T is like this. So more tail probability. So therefore, if this is z, so this is t, this is z, let's say. Both has mean 0. 0.005, 0.05, okay? This is 0, z 0.05. इसके बाद 0.05 probability is here. So t for that it will be greater than 0.05. Simple. Did you understand? Nikhil, did you understand?
Like, can you repeat it? Like, I need to...
Which part you didn't understand?
Like this t is z at 0.05 level, that only.
It's told that if t is, this capital T is normal, then this is 0.05. Therefore, if it's normal, then t must be what? Z 0.05? Did you understand this?
Okay.
Now they are telling that, okay, this t is different. So, this t is actually t distribution. So, it's asking this probability now. This t is fixed always. This t is varying. If this is normal, then this is turning out to be this. So, t must be 0.005. But they are saying this is different. So, they are asking this probability now. So, now the idea is that normal distribution is like this and t distribution is like this. It's much more spread out. And this is normal. So, therefore, this is z 0.005. It means after this, the probability is 0.005, 0.05. Now, since t dash ka is much more spread out, the probability of that will be greater than 0.005. 0.05. So, this is greater than 0.
Okay, I got it.
Okay, perfect. So let's move to the next question. Why did they give this thing anyways? X be a real or unknowable, so that expectation of e to the power x is this, and expectation of e to the power x is e to the power expectation of x, and which of the following is correct? Romit, how do you do it?
I use the data series of E and contact the coefficients.
Very good. And what is coming out?
I think B was the option.
Huh?
I think B was the option.
So what Romit did you understand, guys? Did you understand what Romit did? Using the Taylor series expansion, one can really compare. In Taylor series expansion, one can really compare what is x. So therefore, expression of e to the power x is what? Using moment generating function, he means. So e to the power x is what? 1 plus expectation of x by 2 factorial. Sorry. Left hand side plus the dot is equal to, here it's e to the power this. So it's 1 plus right? So what's happening? It's coming out that variance is 0, right? If the variance is 0, that's a constant function with probability. Now we cannot understand what is expectation of x. We don't know what is expectation of x. So its variance is clearly 0. Expression is greater than or equal to 0. We don't know. Do we know that? No. This we yes know it. This is the third option. And this is something you can easily understand. Probability x is greater than or equal to 0. We don't know a. Once we don't know a, we cannot tell that. And it's like it's single point. So its probability at 1 point, it's 1. So it's coming out to be B, Romit? Huh? Yep. So all of you understood this solution, guys? Very easy. So okay, thank you guys for being here, and a very good night to you. I hope you enjoyed the class, and I will see you in the next problem solving. Bye bye.